Hi everyone, welcome back to Adrian's Digital Basement. On today's video we're going to be working on this very nice example of a Macintosh 128. It was donated to me by a member of the local Commodore Club here in Portland, Oregon and Vancouver, Washington. I'll put a link to the website in the description below, so be sure to check that out. The Macintosh 128 was released in 1984 and was Apple's first consumer Macintosh machine. Now interesting is the 128 stands for 128 kilobytes, which is all this computer had, and it wasn't even expandable, at least not with modifications to the motherboard. This is the original keyboard for the machine, and interesting is you'll notice, of course, there's no numeric keypad, but even more so, there are no arrow keys. Steve Jobs didn't feel that arrow keys were necessary because you should be using the mouse for any type of cursor movement. That didn't last, luckily, and the Mac Plus, which came out not too long after this, had a keyboard that had a numeric keypad and arrow keys on here, so you could at least move the cursor around. You'll notice on the front of the machine, it doesn't say Macintosh or anything, it literally just has the Apple logo. And for 1984, the machine was relatively ahead of its time, using 3.5-inch floppy drives, which persisted on the Macintosh all the way until they stopped having disk drives, with the iMac. This is a 400K single-sided disk drive, which means your capacity is quite limited, essentially requiring you to have an external floppy drive because you would constantly be swapping back and forth between the system disk and your program and data disks. So a second disk drive was definitely required. The keyboard connects to the computer with what looks like a regular phone cable, one that you would use to plug the phone handset into the base. But please note, while this looks like you could just use any phone cable, if you do use a phone cable without rewiring the pins, it will damage the microcontroller that runs inside your keyboard, rendering it essentially useless. Interesting for its time is the machine totally uses convection cooling. There are no fans inside. Taking a look at the back of the machine, Apple was relatively forward-thinking for 1984, giving this computer digital audio, a built-in mouse port, floppy, and 2 serial ports. Note that it wasn't until the Macintosh Plus that the computer had built-in SCSI. Because of the 128K in this machine, it was really limited with what programs it would run. So a lot of Mac 128s were upgraded very early on to the Mac 512. So it's hard to tell when you're buying a Mac 128 if it even has the original 128 motherboard or the 512, not without taking the board out and taking a look at it. On all of the Macs, like the Mac 128 through the Mac Plus, there is a little door here which holds the battery compartment that's used for the real-time clock. If you get one of these computers, make sure you take a look inside here and check for corrosion. It's pretty common for those to leak. Usually you just get a little bit of corrosion on these two pins, which you can clean off with some vinegar, but just this is something to watch out for. If you want to know what model number and serial number your Mac is, the serial number sticker on these old classic Macs is found underneath the monitor. So model number M0001 is the Mac 128, as we can tell from the back of the machine as well. The serial number can be decoded to tell you exactly when the computer was made and in what sequence, and I'll overlay that information on the video. If you've ever taken a look at a classic Macintosh and you've wondered what these things are on the side, Apple installed this little plastic thing here which gives you 2 extra buttons externally on the machine. One is a reset button and one is an interrupt button, which is kind of like a hardware interrupt, sort of used for debugging. If you do have these on your computer, you have to take these off before you remove the back cover or it will break these. Interesting also on the left side of this machine is it may be hard to see in the camera, but there's a shiny section of the case here. And what that is if you feel with your fingers, if you slide your hand towards the back of the machine, you can feel the smooth part, and that means the power switch is right behind there. So if you don't know where the power switch is, you can feel around, like nope, there's the smooth part. There's the power switch. So this is going to be a little bit of a repair video because this machine has a fault right now. Let me plug it in and show you what it's doing. Okay, the power is plugged in. If I turn the switch on, I hear the floppy drive. Sounds like it's trying to access the disk, but there is no picture. And moving the brightness knob either way, nothing. So when I turn this on, I did hear the high voltage start up. Although since this monitor operates at higher than 15 kilohertz, I can't hear any high frequency whine from this computer. But definitely we have no image, but at least we're getting the normal startup sound and floppy drive sounds. So let's open this thing up and see if I can figure out what's wrong. Hopefully something simple. Alright, let's get this thing off the side of the case. It has little notches on it, so I assume that pulls it off. Ah, yes it does. So all of the screws on the Mac are just a very standard Torx bit. And unfortunately, the two that are at the top are very deeply recessed in there. So if you have a normal screwdriver set that say has a little Torx bit like this where you use a nut driver, this will not work in there because when you try to get this screwdriver down into there, the shaft here is too thick and it will get stuck in there. And if you saw Parafractic's video, when he tried to open his Mac Plus, he had that problem. So don't do that. The thing I recommend you do is you take a regular Torx bit, one that fits inside these bottom screws, which are easy to test with, and I notch the bottom of the bit. And that allows me to use a very long and skinny flat blade screwdriver to take out those two at the top. And I'll give you a demonstration on how this works right now, but this is my no-cost Mac cracker. Okay, so for the back screws, I'm just gonna use a standard nut driver. And I'm gonna take these off. It's all pretty easy. And then for the two down here, what I do is I take the bit and I just drop it down into there. Take my flat blade, very long screwdriver. And of course the hardest thing is getting it aligned with the slot that I did. It would have been nicer if I maybe did a cross so I could use a Phillips. But this does work, and you just gotta fiddle with this for a sec. There we go. And then you just sort of tilt the computer back to get that bit and the screw out. Well, I got the bit. You do the same with the other one. Taking many Macs apart like this. So I tilted it back and neither screw came out. I'm just gonna try to split this up, and hopefully, there we go. And then we just lift the back off, like so. Very interesting. I've never opened a Mac 128. I noticed right off the bat, there's no RF shield like there are on the later models. So at that point, the two screws just fell right out. So now I have all five out. And now we get our first look inside the Mac 128. Now right off the bat, there's definitely a little bit of corrosion right here. It's almost like some water dripped through the top of the case onto this metal here. So that kind of sucks, but it sounded like the machine was still working. We're going to check every connection, and I'm going to power this up, and I'm just going to like poke around with a non-metallic screwdriver and just see if the picture comes back by poking it. I have a feeling what's probably wrong with this is a bad solder joint on the analog board here, so we have to remove this plastic cover to see that. Let's see what happens if I turn this on. Nothing I do poking around seems to do anything, so let's take out the analog board. So to remove the analog board, we will need to discharge the CRT because the high voltage anode cap is connected, and I did just run the machine a minute ago. So make sure you discharge it first. I'm not going to show you how to do that on here. There are lots of other YouTube videos, but as it says here, warning high voltage. This, while it's running, is about 15,000 volts, so do not service this machine when it's connected, or you can get a nasty shock. Getting the analog board out is easy enough. There are two screws on the side here, one screw down there, and once you disconnect the cables, like this is for the deflection yoke, it just lifts right out of the computer without any difficulty. I took a moment to clean up the CRT right here, just sort of wipe off a lot of the black soot that was sort of accumulated there. All right, here's the analog board. And right off the bat, I see a problem that's probably not related to our black screen, but something I need to address immediately. And it's right there. One of those damn REFAs. It's an X-Cap 0.1 microfarad, and this hasn't blown. And let me tell you, this will blow. There's one thing I have to warn you about between the Mac 128, 512, and Mac Plus, is the REFA filter cap is connected to the mains input all the time. The power switch is after the REFA. So if you just leave this plugged in, even if the computer is off, that thing can blow. But yeah, everything else on the board seems okay from initial inspection. The caps are all looking good, no leakage or anything else funky going on. So what I need to do is take off this plastic cover on the back and check for broken solder joints, and I'm going to expect to find some. So I've worked on these analog boards on other Macs, and they were held on with these little plastic clips you pulled out, but not on this one. This is held down by some foam double-sided tape. So once I pull this off, it's not going to go back on very easily. They are crusty as. Other than the blown REFA, I don't see anything wrong on this board. All the solder joints look very, very nice. Nothing out of the ordinary at all. So, okay, let's think about process of elimination. When I turn the computer on, it sounds like it boots, but there's no picture. So the problem is either on this analog board, it's either the CRT itself, maybe the filament blew out, or it's the motherboard itself that's not generating the video signal. Now, the easiest thing for me to do right now, instead of trying to troubleshoot the video path and whatnot, is to just test this motherboard in another computer that has working video. Here is a working Macintosh Plus. Well, actually, I do need to open this up because its Rifa cap blew out, but otherwise it works. And the motherboard from the Mac 128 all the way through the Mac Plus are all compatible with the analog board. So I can just plug this motherboard right into the analog board on this computer, and we can see if we get a picture. So let's crack this case open. Okay, so Mac Plus is open, and this is the Mac 128 motherboard connected to the analog board of the Mac Plus. You can ignore this stuff here. This Mac Plus actually has a 68020 accelerator in it. I'm not going to talk about that in this video. That is for another video. This was my father's computer, this Mac Plus, and he added that accelerator at some point. He used this machine as his primary business machine for desktop publishing. So I will get to that video where I show that thing. Okay, here we go. Let's see if this works. Good, we got the regular old power beep. Ah, yes, we have picture. All right, so awesome. So we know that there's nothing wrong with the motherboard, and the problem lies entirely with the analog board of the CRT on the Mac 128. So okay, that's something we can work on. So while I have the board out, I want to talk about something. So this is one of the early Mac 128 boards because it has a ceramic 68,000 package. And look at how it says Apple on there, but 1983. They were one of the early manufacturers using this chip. So I know the very early 128s had this ceramic package, and then it moved to the black epoxy like the rest of these chips. But this machine's actually been upgraded to 512K. So someone went and actually desoldered all the RAM chips and then reinserted these 256 chips, strangely not putting sockets. Like, why not? And then there's this little board here, which is part of the modification to enable 512K. And the other thing is this resistor flat pack here is connected to 3 pins or 3 or 4 pins on this chip here. What is this, like a CIA or something, 6522, and 1 pin right there. If we look at the side here, this little board, which is like a little custom PCB, is mounted on a little thing there, a little pin header. We can actually take it off. Now on the original motherboard, there were just holes there, and I've seen some modifications where people ran sort of wires and they piggybacked this logic IC on top of one of these other ones, switched out the RAM, and then added this resistor using standard quarter-watt resistors like this. So this was a really clean upgrade to 512K. What do you guys think? Should I keep this as a 512K or should I revert this back to 128? Now I don't want to desolder these chips, but I'm sure if we just remove this and this, the machine will go back to being a 128. Even though it has these 512 chips in here, the extra address line just won't be used and it will register as 128 again. What do you think? Let me know in the comment section below, and I'll do the mod as per what you guys say in the comments. By the way, take a look at this. This right here is the blown up paper Rifa filter cap. It's an X cap, so this is pretty horrible. And yeah, this was just plugged in and I was in the other room and I heard hissing noises and I came downstairs and there was a bunch of smoke. This machine was off, but plugged in. So, Mac Plus. Oh boy. You damn Rifas. I will be changing this out on the Mac Plus, but again, that's for a different video. So this is the Mac 128 analog board, and I've replaced the Rifa 0.01 X2 capacitor. I did manage to really screw up one of the pads. It was hard to get the Rifa off. Its pins were bent far over, and it was just really difficult, and these pads just came right off. So I just bent the pin over, added a little extra wire. That is done. So I started thinking about what exactly is the problem here, looking very closely at the board. I think I found the issue. All right, so this is the connector that goes to the motherboard, and pin 1 is the composite video. And you know what? That looks cracked. In fact, these first 2 pins look cracked. Can you see it on the video? It's hard to see on my camera screen, but there's definitely appears to be a crack there. So I'm gonna reflow these, and we're gonna put this back in the case and see if that does the trick. Okay, so my camera crashed there, so I don't know what I actually caught. So what I've done is I've reflowed all of these pins. That goes from the cable that goes from this board to the motherboard. I reflowed these 4 pins right here. They're sort of under this foam. One of them looked dodgy, the other 3 look fine, but I did all 4. Those are the ones that go to the deflection coil. And then this pin over here, there's another connector there. That one looks a little crappy. So I suck the solder off first, like that. And then I use the heat of the desoldering iron. I add a whole bunch of new solder. Okay, I think we're good. I think we're good to go, and we're gonna test this out. Let's put this back in the Mac 128. Okay, so do I remember how this goes back in? Not really. So it has to slot in here. The knob has to be turnable. There's these little things here that hold the bottom of the board up. And then what's really essential is you need to make sure that this is connected to the chassis. This is the ground that grounds this to the board. And if you don't have this screwed on properly, it's not going to be fully grounded between the analog board, which has the flyback, and the CRT. So just make sure you got these screws back in. So I have a little cup here that has the screws I need. And the little ground pin has this small little metal thing you slide over. And then there are these little black screws that go in. Then here, there's a little ground wire, which you connect to the chassis. I have one more small black screw, so there must be another screw. Okay, so I think the last screw goes right in that hole, right there. I can see a little bit of witness marks, as the clockmakers say, and it shows where the screw was once resting against the PCB. I'm not putting this back on yet. This piece here, this will need to be stuck back on for safety reasons, but just for testing, we're going to test with the board like this. All right, let's connect some of these cables. Power cord to the motherboard. So this goes down here. Okay. Then here is the cable that goes from this connector to the CRT. I reflowed these solder joints as well. Let's push that on. And then this connector goes onto the CRT. You also have to be very careful with this. It only goes on one way, but you don't stress it out. And now we have the high voltage lead to connect. I'm going to take a little bit of grease and just smear it around the edge on the outside. It just helps promote a good seal. Just a little bit on your finger. We're just gonna smear this around. I will struggle to get these back on because this is old and crusty, but we're going to give this a test. You got to get one part underneath, you know, the little opening there. There's sort of a little ledge in there, and you got to squish the other one in. Get them both underneath the ledge, so it's a nice solid connection. There we go. Got it. So give it a little tug. It's on there nice and solid. Let's do a sanity check. Floppy drive. I'm not going to connect the floppy drive just because it needs to be cleaned. I don't want to run it because it might strip the gear, so I'm not going to connect that. But we're just going to make sure everything else is connected. So the ground here is connected. I have the screws connecting the chassis to the analog board. Flyback is connected. Ground is connected. Everything looks good. So I think I'm ready to actually power test this. So this side of the board, because I don't have this white plastic cover, is extra dangerous. So power cord. Power switch is off. Good. That X2 cap I put on, the refill replacement, didn't blow up or anything. Here we go. Okay, we got the beep. Uh-oh. That is, see, my double checking. Did you see? There was a little dot there that appeared in the middle of the screen, so I shut the screen off immediately. And that is because I forgot to hook up the deflection coil. See, even though I was double checking and saying I was going through my checklist, I didn't finish it because the deflection coil cable is sitting right here, not connected to anything. And it plugs in up there. So I'm gonna route this up here. All right, now the deflection coil is connected. So let's try that again. Okay, here we go. Oh, look at that. So you don't want to leave, when I had the deflection coil unhooked, it just had a single dot in the middle of the screen. You don't want to leave that because you make a little permanent mark in the phosphor. Yes, there we go. It's clear, it's pretty sharp. There we are, Mac 128 fixed. All right, so there we are. So in summary, what I did is I took the computer apart, inspected for bad solder joints, but I didn't initially see any. So I connected the motherboard to another one of my computers, a Mac Plus, just to make sure it wasn't the motherboard. It worked fine. So then I knew it was something with the analog board or the CRT. So most likely it was the analog board. So I re-inspected again, looking for bad solder joints, and sure enough, I found a couple. And of course, if you have one of these machines, you have to replace the Rifa filter cap. It's just a matter of when it's gonna blow, not will it blow. If you are trying to troubleshoot and you have one of these classic Macs, the Dead Mac Scrolls is a PDF you can find by just Googling, and it has a lot of great information about specifically what you can look for with different symptoms and parts to replace. So it says if the Mac does this with a squeal and a noise or whatever, then it's probably this component or this component or this component. But luckily in my case, it was just some bad solder joints. So all that's left for me to do is just clean this disk drive and re-lubricate it, and then I'll have a nice working Mac 128. So again, my question for all of you is, should I revert this thing back to 128K, or should I leave it as 512 and just call it a 128 even though it has 512K? Let me know in the comment section below. You can subscribe for more videos that I'll be making in the future. You can thumbs up this video if you liked it, and of course if you didn't, you know what to do, thumbs down. Anyhow, thank you very much. Goodbye. And that allows me to use a very long and skinny flat blade screw.